next topic นะคะ from the Jittrerat Chinvorarat in the title of the cleansing performance of the crude extract from the fresh and dry Litsea glutinosa leaf from petrochemistry and polymer science, Chulalongkorn University. Okay, thank you. Okay, start now, please. Jittrerat, turn on the microphone, please.
Hello ค่ะ can you all hear me?
Yes.
Okay ค่ะ Okay, I would like to start my presentation. Good afternoon to all the committee and fellow participants and the audience. My name is Nang Sao Jittrerat Chinvorarat. I am a master's degree in program in petrochemistry and polymer science from Chulalongkorn University. And here today, I would like to present the title of my research of the cleansing performance of the crude extracts from the fresh and dry Litsea glutinosa leaves. Okay, the outline or my presentation will consist of 4 parts, which start with the background of this research, the material and methods, results, discussions, and conclusions. Without further ado, I would like to begin with the background of this research. Synthetic detergents, it could be none other than an everyday product that we use today, which is a shampoo. And for a shampoo, it is an essential hair care product, which was developed to cleanse the hair and the scalp by eliminating undesirable sebums, excessive oil, dandruff, and dirt, which only water alone cannot remove most of these. One of the major components of a shampoo is called surfactant. And for a surfactant, at a certain concentration, it will produce or form, which is called a micelle. If you look at the picture on the right side right here, a micelle, it forms, it looks like this in terms of 2 parts, which is on the heads and the tails. On the head part, we could call it as being as a hydrophilic, which means that it attracts only water. And on the tails, it will be called as a hydrophobic, which means that it attracts anything else except water. So for example, as we use a shampoo as an everyday product, each time we cleanse our hair, how the micelle works in this case is that they, on the tail part right here, it will attach anything that is not water. It could be dirt and oil, and it will be get rid of or being eliminated after we cleanse with water in the last stage. However, as being a shampoo, it is an affordable product. It could be used every day, and it has been to present to our lives, and it has also been at low cost, so it's affordable to everyone. But however, a shampoo, which is a synthetic detergent, also could have a negative impact in both of the health and environment, because a shampoo can also leave chemical residues on the scalp, which can cause skin allergies. It could be causing itchiness and dryness. And also because of these chemical residues, can also damage the environment by releasing non-biodegradable chemicals. So what is an alternative for synthetic detergent for this solution? One of them is being a natural detergent. A natural detergent are mostly a plant-based component, which means it can be used at any parts of the plants. It could be its leaves, roots, or barks. And due to being a natural detergent or plant-based, it is also being due to their biodegradability, it also helps in terms of lowering the number of health issues. And is also designed or manufactured in such a way to be more eco-friendly. And more to that, it's the best part of being a natural detergent is that they are free of common chemicals such as artificial fragrance, preservatives, colorants, and other synthetic additives. For example, if we use a harsh cleanser as we wash our clothes today, it also contacts with our skin. It leaves with the skin irritating. But for natural detergents are different. natural detergents are hypoallergenic, which means that it helps people who has a really, like myself, I had a really sensitive skin. So it helps me with the clean clothes, being more comfortable and non-irritating. As I mentioned about having a natural detergent as an alternative to synthetic detergents, there's one particular plant that has not been studied scientifically, which is called the Litsea glutinosa. The Litsea glutinosa is a rainforest tree that could be found in India, Australia, some of the Western Pacific Island, including in Asia, could be found in China, Vietnam, and the North region of Thailand. In Thai, we call it in terms of bai mi or ton mi. Other common names, it could be called as Indian laurel or burley beech. It has a tree height of 3 to 15 meters, as in the figure above. It contains green yellowish flowers, and the fruits size is about less than a diameter. The flowering occur for the Litsea glutinosa was about during March to June, which is about this time of the year. And its fruits will be occurred later on September and October. What interested us about this particular plant is that in the past, people use its leaves itself. They use the leaves to rub together with water, and when they rub it to a certain point, it will produce a mucilage right here. A mucilage is a thick mucus substance, and they claim that they will use this to cleanse the hair. And more than the leaf parts, for Litsea glutinosa, they can also use its bark part. It can be used as a demulcent, which means that it is good for soothing or relieving the pain for diarrhea. Well, even though the Litsea glutinosa leaves has been used as a traditional shampoo before, there has not been any research much about this plant. So we here like to study its potential of becoming a natural detergent or natural shampoo by here reporting its ability of being able to have the foam power, foam stability, and hair cleansing performance. There are 3 objectives of this research is that we would like to compare the mucilage solutions of both fresh and dry leaves by varying the solid concentrations or solid contents for foam power and foam stability. And the second one is that we will also evaluate the hair cleansing performance or its ability to remove how much sebum from the hair itself. And lastly, we will also determine whether either fresh or the dry leaves are becoming a potential natural hair shampoo. Other research or similar herb parts, in this case, I will bring 4 examples. The first one on the left, it's called the shikakai. Its full name is called Acacia consina. They claim that they use the dry pods, were traditionally used as a hair cleanser and also for dandruff control. The second one is called the Rita. They use its fruit coats, which in this term fruit coat, it means the cell walls of the fruit, the inner layer, that's what they claim, also works as a natural shampoo. The last 2 on the right side belongs to the same family as the Litsea glutinosa, belongs to the Lauraceae family. The first one is called the Litsea coraceae. This also provides its leaves for the hair growth and also can also cleanse the hair either. And the last one is called the Litsea whiteana or knees in the short term. These can also use its leaves to reduce dandruff and excessive oil from the hair. Okay, I would like to begin with the material and method of this research. It will be breaking down into 3 parts. The first part, it will be go with the the hair preparation. The second part will go with the foam power and foam stability. And the last part will be going with the hair cleansing performance. So starting with extracting the Litsea glutinosa leaves for both fresh and dry leaves. First, we will collect the leaves. In this slide, we collected during the time of March 2021. We use about 10 grams of the fresh Litsea glutinosa leaves, and we will soak it in water, which is the amount of water about 1 liter. And then instead of trying to rub it with our hands in the for the local people that use in the past, we use a blender instead for a better paste. We use a blender to blend the whole leaves and water to reduce the mucilage. at a lower speed for about 30 minutes. And then after 30 minutes, we will leave. We will let it sit in the room temperature and constant stir for another 1 hour. For dry leaves, goes with the same process as fresh leaf, but instead for dry leaves, we actually use the fresh leaves and put it in a hot oven for 60 degrees for about six hours. And then the dry leaves will also go through the blender and blend for another 30 minutes. And instead of stirring a constant stir for 60 minutes, the dry leaves will also be stirred for 180 minutes, which is about 3 hours. I will explain why we make more time for the dry leaves in this case. And now we would have both fresh and dry leaves, and then we'll go through filtration. In this case, we use a vacuum filtrating using the Whatman paper number 42 to extract the crude from the solution itself. And then we will use the centrifuge to make to you a better clear mucilage solutions of both fresh and dry leaves in this case. And then we will produce, which is about a big batch of these two. This is the both fresh. On the left side is the dry leaves mucilage solutions, and on the right side is the fresh leaf mucilage solutions. And up to this step, then we will concentrate it, both fresh and dry leaves, which the point of concentrated means that we will remove some of the water out to make it more concentrated. But in this term, we will be calling that varying in solid contents. So in this case, we will have about the range of 6 solid contents for each fresh and dry leaves, which means we will have a total of 12 samples. And then with this varying solid contents, we will also proceed into determine the foam power, foam stability, and hair cleansing performance. Okay, for the second part of the experiment is that we use a foam power test. The glassware that we use right here is about 25 milliliters of a volumetric flask with a stopper. This has been customized, especially for this experiment. Also, how we produce the foam is that we invert it about 150 times, which is about 30 inversions per minute. So let's say about 5 minutes per one sample. And this is the picture of before the shake and after. You can see the foam produced right here. After we shaked it, we will record it as the foam power gradually decrease. We record it to about 120 minutes, which is about 2 hours. And the foam power in this case, we will go by VP equals V1 minus V2. The V1 is the volume of both the foam and water, and V2 is only the volume of just the water. And our last part of the experiment is that the hair cleansing performance. We will be preparing the hair. This is a virgin hair that we prepare, which is about 8-inch long of the hair. We divide it into about 1 gram per each, which this section only here, we only use the 6-inch section, even though it's 8 inches long. At first, we will wash it with 5% of SLS, which is the sodium lauryl sulfate. It's another anionic surfactant to get rid of the dirt or any excessive oil before going to the next step. Okay, and then we would go with creating a synthetic sebum in this case. The synthetic sebum, this has been modified by another research paper. I have been using her type of creating sebum formula, which consists of olive oil, 20%, 50% of coconut oil, 15% of oleic acids, 20% cholesterol, 15% of paraffin wax, and 50% of stearic acid. All of these were mixed, combined, and heated to about 60 degrees. It will form like a wax, a solid wax. And then we would took about 10% of that synthetic sebum will be dissolved in hexane, which is about 25 milliliters. And afterwards, after we had the synthetic sebum dissolved in hexane, we would dip the hair, the samples that we prepared to get the greasy hair. And then after we dip it about 10 minutes per sample, we would take out the hair and weight it to see the weight of the sebum on the hair. the percentage of sebum removal goes by the formula right here is WDH minus WSRH times 100 divided by WS, which WDH is the weight of the BC hair minus by the weight of the hair after the sebum is removed. This is a term of after it has been washed by the fresh and dry mucilage, and the control, which we will use another surfactant as a control to compare both fresh and dry leaves. And then lastly is the weight of the sebum, only the sebum on the BC hair. Okay, on the next presentation slide will be on the results and discussions. Okay, I will be breaking down the foam power and foam stability one by one. This is a graph of time going by foam power. This is the dry leaves mucilage. As in this case of term, in figure 1b represents the foam power and foam stability of the dry leaves with various solid contents. In this case, we will have about 6 range of solid contents for the dry leaf, which is about 1.2, 2.5, 4, 5, 5.8, and 7.6. From these various solid contents also produce the VP, which is the foam power right here at the first topic right here. It produces at 0.75, 1, 1.25, 1.5, and 1.75, and 2 as the highest foam power. So how it worked is that after the foam power has done, it will gradually slow down, or the foam power suddenly collapse. Or if it's luckier, or if it's a good foam power stability, it can go longer into 2 hours. In this case, it could work only with the solid content at 5.8% and 7.6, which is the red and green line over here. Anything else below than 5.8, which is these solid contents, it only stayed until 20 minutes, which means over here after 20 minutes, the foam collapsed. It could not be calculated anymore. This is the dry leaves. And for the fresh leaves right here, we can see a significant differences from the fresh leaf and dry leaf. For the fresh leaves, we can see that the foam power is much higher than the dry leaf itself. And most of them, except the solid content of 1.7, which is the last line of was collapsed after 20 minutes. In this term, we can see that even though the solid content of the fresh and dry leaves will have similar solid contents, we can see that in terms of fresh leaves, a solid content at 9.2 and 6.3, which is over here. It's actually the red line and green line, it overlaps each other. For the red line, which is a 9.2% of solid content, it has the highest VP foam power of 2.25 milliliters, and it can also last long until 2 hours, including all of these other solid contents for fresh leaves. And our last result, which is the hair cleansing performance. Okay, on the right side is representing the dry leaves with various solid contents, and on the left side, it represents the fresh leaves with various solid contents. We can see that the first 2 columns, we use the SLES. The SLES is a sodium lauryl ether sulfate, a commercial detergent. It can be found in many cleaning products, which we use it as a control to see if the percentage of sebum removal of the dry or fresh leaf nuclei could beat this number, which we thought that it couldn't be possible. But in this case, we can see that for using only the commercial surfactant, it can remove up to 93.7% of the sebum, total of the sebum. For the dry leaves mucus solution at the solid content of 1.2, at its lower value of removing at 46.1, which means that after it has been washed with the dry leaves of the hair, it still leaves some of the oil sebum on the hair. And its highest sebum removal at 64.7% is still lower than the fresh leaf of its lowest solid content value of 1.7 right here. But then as you can see, during this study of the hair cleansing performance, we actually discovered that the Litsea glutinosa mucus solutions with lower solid contents could easily be rinsed out of here, while the mucilage with a solvent of 10.1 right here, why even it's higher in terms of solid content, why does the percentage of the sebum got lower? We kind of conclude that maybe if there will be an optimum value in this case, if it's too high in terms of solid content, it will be harder to wash off the sebum. But if it's too low, it's kind of like being too diluted, so it doesn't cleanse the hair as good as we thought it could be. And furthermore, we can see that for the fresh leaves at 9.2 solid content, we had the highest of it at 79.2, which is a bit lower than using the surfactant itself at 83.5, only at 1%, which means that, okay, the Litsea glutinosa for fresh leaf worked. It could be a hair cleanser for the future terms. So this is a conclusion for the experiment, is that for the fresh leaf Litsea glutinosa leaves at solid content of 9.2, as I mentioned before, it actually showed a great capability of being optimum value as a natural shampoo. And moreover, it showed a better stable foam stability and more foam power than the dry leaves. And then we would have the hair cleansing performance also showed that the fresh leaf would almost move 79.2 of sebum compared to 1% of SLES, which means that it can remove most of the sebum comparing to, let alone a synthetic surfactant. And then our last conclusion is that fresh leaf mucilage solutions show the potential of being a natural hair shampoo, that it can remove hair sebum with good foam power and stability rather than the dry leaves. And also by the hair cleansing performance, it showed a better in terms of the percentage of removing the sebum percentage, and also can cause good foam power and foam stability than the fresh leaves. Okay, before I end my presentation, we like to thank we like to thank the Wachapisex Pope Endowed Fund for the RCBC Research Unit, as well as the Department of Chemistry, Faculty of Science at Chulalongkorn University for their partial financial support on this research facilities. Okay, I would like to thank you all, the committee and audience. I would like to end my slides right now, and any questions I will be answering after this. Thank you very much.
Thank you very much. Very nice presentation from Jittrerat. I would like to open the floor to ask a question. Okay, any question?
Again.
Yes. Okay.
Again, Ajahn Panida. Yeah. Sorry about that. We take this opportunity before you. So it is very interesting topics, and I think after these presentations, you will make a new brand of the shampoo, right? We see a brand of shampoo in the supermarket. That is.
We thought of making a product if it showed the potential. I've talked to my advisor about this before too.
That's nice. That's nice. By the way, I'm going to ask you something that is not very academic point of view. I would like to know that you show that you have a high performance of hair cleansing, which is very good. But I would like to know that would it will not be will not cause hair to be too dry. You know what I mean? Normally, if you have a very good cleanser, it take everything. I don't know what to say, but it can make the hair too dry. Do you consider that factors?
Do you mean like the time for the hair to be dried after being washed?
No. I mean, if you use this shampoo, do you test for the moisture in the hair, because the hair can be too dry, and then you
okay. I used to test it on my own hair. On this case, okay. I found that it did get rid of some of the oil, but the point for this particular leaf, that it also leaves some of the, how do you say, it's mucus left on the scalp, some of it, not too much. It does make our hair a bit shinier, a bit oilier than it it's supposed to. For the drying part, I think it took a bit longer than a regular shampoo ค่ะอาจารย์
Oh, okay.
A bit longer.
Okay, that's nice.
ค่ะ
So I hope this shampoo can good for hair protections as well in the future.
ค่ะ
Okay, thank you, Jampanida. Thank you.
Okay. Any question? Okay, I have question. When you extract, you use cutting by blender at low speed for 30 minutes. I
Yes.
think it's very long time. Have you ever tried to use the high speed and a short time? I think it's like coconut milk. I think allowed like that, but very short time. I'm not sure. Have you ever tried to do that?
I used to go with the higher speed for this leaf ค่ะอาจารย์ by using water. Then the result is that for this leaf, it needs to use like how do you say, a shear force between the leaves instead of going with the high speed. It doesn't mean like the more higher speed, it will produce more mucilage. In this case, that's why the people from the past, they kind of like, they use their hands and put it in the water with this leaf, and they kind of rub the leaves the whole day. So for me, I think it could go with a better speed, but the result for extracting the mucilage, it doesn't produce as much as I want it to be. That's the problem for using if I use too high speed for it in this case.
Yeah. And you use the water to for the solvent, and you have another solvent to extract. I mean alcohol or petroleum ether or
for this case, I wanted to extract just the mucilage, but the thing is I use methanol and ethanol before. It does not extract mucilage at all. It extracts other component which is not related to the mucilage. That is why I use just only water.
Okay. And the last comment, you should study about anti-drop.
I'm working on that, ค่ะอาจารย์
And okay, thank you very much. No, Jittrerat again. Okay. And the time up for this section.
Okay, thank you, Associate Professor Pranida Chamkiat Gong in this section.